Hello friends, hope you all are doing well. Welcome to Ace Chocha Point. Today we'll learn motion and the laws of force. Here we are going to do only theory and the theoretical part of motion and the laws of force. From describing a moving point to Newton's three laws, how objects move, speed up, collide and conserve momentum. So, we'll go through motion needs a reference point. To describe the location of an object, we need to specify a reference point. That's called the origin. So, positions of an object on a straight line path. School, then A, then village. For example, a school is 2 km north of a village. This describes the position of the school with the village as the reference point. The total path length covered is called the distance covered. Displacement is the shortest straight line distance from initial to final position. There are two ways to measure a journey: distance and displacement. So, the total path length covered by object, regardless of direction, always positive, never decreases. That is distance. OA plus AB equals to 60 km plus 25 km equals to 85 km. Next come displacement. The shortest straight line distance from the initial to the final position with direction. OB is the straight line equals to 35 km. We'll go through uniform versus non-uniform motion. So what is uniform motion? Equal distance are covered in equal intervals of time. However small those intervals may be. A car covering equal distances every second on a straight highway. What is non-uniform motion? Unequal distances are covered in equal intervals of time. A car speeding up and slowing down in a city traffic. Next is speed, that is distance covered per unit time. So average speed is total distance travelled upon total time taken. SI unit is meter per second. Also kilometer per hour. Speed with direction is called velocity. It is the speed of an object moving in a definite direction. Worked example is Usha swims 90 meter in a pool and swims back the same 90 meter in 1 minute. Total distance covered is 180 minutes. Total time taken 1 minute, that is 60 seconds. Average speed is 180 meter divided by 60 seconds is 3 meter per second. Displacement after 1 minute is 0 meter. Average velocity is 0 meter per second. So this is how we calculate. Now acceleration. So A equals to V minus U upon T, where U is initial velocity, V is final velocity, T is time taken. Its SI unit is meter per second square. It's a formula for acceleration. So uniform acceleration velocity changes by equal amount in equal time intervals. For example, a freely falling body. Non-uniform acceleration velocity changes by unequal amounts in equal time intervals. That is example, a car in traffic. The given example is, here is a force of 5 nano gives a mass 10 kg and acceleration of 10 meter per second square and a mass of 20 kg and acceleration of 20 meter per second square. What acceleration would it give if both masses were tied together? You can solve it by this formula. You will get an answer. A equals to 5n upon 30 kg equals to 0.167 meter per second square. We'll go through the graph that is distance time graph. Uniform speed as well as non-uniform speed. You can see on my screen it has given in uniform speed distance versus time and non-uniform speed distance versus time. In uniform speed, a straight line graph means the object covers equal distance in equal time in a uniform speed. And non-uniform speed, a curved graph means the speed is changing over the time. Velocity time graph. The area under a velocity time graph equals the distance or displacement travelled by an object. First, uniform velocity, that is a straight horizontal line parallel to the time axis. Uniform acceleration, a straight line sloping upward or downward at a constant rate. And the third one is area equals to distance. For uniformly accelerated motion, area under the graph gives distance covered. 3 equations and 1 idea. For an object moving uniform acceleration, starting at velocity u, reaching velocity v after time t and covering distance s. Velocity time, that is v equals to u plus at. Position time, that is s equals to ut plus half at square. Position velocity, that is v square equals to u square plus 2as. So worked example is given. According to these formulas, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming uniform acceleration, find the acceleration, find distance travelled. U is 0, V is 20 meter per second, T is 300. We'll get A equals to 1 upon 15 meter per second square. S, that is distance travelled, is 3000 meter, that is 3 kilometer. You can use this formula, place the value and have the answer. Next is uniform circular motion. When an object moves in a circular path with a uniform speed, its motion is called uniform circular motion. V equals to 2 pi r upon t. R is radius, t is time for one revolution. Though the speed stays constant, the direction of motion keeps changing at every point. So velocity is not constant. This means the motion is accelerated even at uniform speed. Examples: the moon orbiting Earth, a cyclist on a circular track, an athlete on a curved race track. Part 2, that is force and law of motion. We'll go through balanced and unbalanced force. Balanced force. Net force is 0. No change in the state of motion. A stationary object stays still. A moving body keeps its velocity. A book resting on the table. Now we are going through the forces. That is part 2. So next is unbalanced force. Net force is not 0, produces a change in speed or direction, causes acceleration, pushing a box hard enough to overcome friction. The law of inertia. An object continues to be in a state of rest or of uniform motion along a straight line unless acted upon by an unbalanced force. Inertia of rest. A resting object resists being set into motion, that is a coin flick of a card left behind. Inertia of motion. A moving object resists being brought to rest. For example, passengers jerk forward when a bus stops suddenly. Inertia proportional to mass. The greater the mass of an object, the greater is inertia. Mass is a measure of inertia. Next is Newton's second law. Force equals to mass into acceleration. The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. P equals to mv. Momentum equals to mass into velocity. F equals to ma. SI unit of force kg meter per second square newtons. And 1 Newton equals to force that produces 1 meter per second square acceleration in a 1 kg mass. Worked example are given. You can apply the formula and you can have the answer. Newton's third law is every action has an equal and opposite reaction. So recoil of a gun. The forward force on the bullet has an equal and opposite backward force recoil on the gun. Acting on different objects. Action and reaction always act on two different objects, never on the same one. Simultaneous forces. Action and reaction occur simultaneously. Neither force exists without the other. Next is conservation of momentum. In an isolated system or no external force, the sum of momenta of two objects before colliding equals the sum after collision. m1u1 plus m2u2 equals to m1v1 plus m2v2. Worked example, that is recoil of a pistol. A bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? You have given the worked example. Using that formula you can have the answer. Next is the key takeaways. These are the main recap of this session. Motion basics. Distance is path length. Displacement is a straight line. Change in position. Graphs tell the story. Distance time, velocity time graph reveal speed, acceleration and distance covered. Newton 3 laws, inertia F is equal to ma, and equal and opposite reactions govern how forces change motion. Last is momentum is conserved. In any isolated collision, total momentum before equals total momentum after. So this is it from today's session. Hope you have learned something new and it has increased your knowledge. Please like, share and subscribe and press the bell icon to never miss an update. Till then, keep learning and keep growing. Thanks for watching.